So what we have here is question with regards to finding maximum depth, and we for this item we already see that it's using a DFS, and obvious that it's gonna use different methods to actually solve the depth, but for this case we use DFS. So without further ado, let's establish every single thing, and the character we're gonna like try to introduce for this case is gonna be 3 obvious. And falls under the category of DFS, depth first search. And for conditions, we're gonna cast spells based on our character, and based on the Leetcode question, we always have some form of like rule book that we have to actually obey, and so we want to come in here and actually take a look at their payout series on see how they actually try to solve the whole entirety of the question itself. So cool. So they already start stating already saying that we're going to follow this rule, which is this formula per se, is that 1 plus the max of the DFS of the left or the right. So the max of this. So whenever we go into each of the nodes itself, we straight away just keep on reiterating this, and that's the whole game plan for this whole entirety thing. And I like to actually just say that the core objective of this Leetcode question per se is this, is that we want to try to find the maximum depth. So for this 7, it's gonna be 3, and for 15, it's gonna be 3 as well. But I don't care if it's 15 or 7, as long as you give me the deepest item, that's it. So like the core objective is really to actually just find out the maximum depth, right? So we go out the payout series. So now, cool. We come to the 3, and so we start implementing, okay, I mean, this item is this. Cool. I mean, this item represents a depth of 1. Cool. Are we able to actually enter deeper? The answer is yes. So straight away, we sort of like ignore this value per se and come to here, and then we start asking the same questions. Can we do a 1 plus the maximum of left and right? Both are empty. So for this case, it's going to just return a value of 1 in this left tree per se. And now we do the same thing. We come to here, we ask the same questions. I want 1 plus the maximum of left and right. So it's going to take a look over here per se. Like before this, we're going to enter into 2 subtree per se. So we're going to ask the same question coming to here and here. So at the 15th, we're going to ask these questions, and obviously the answer is just 1, so it's going to be 1. And this question is going to ask itself 7, it's going to ask itself, it's going to be 1, and we're going to pop it back up. And once we pop this back up, it's going to start asking the same old questions, and obviously either one of them is cool. So you 1 plus the max of either side is actually 2. So you pop back up again, is this item. It's gonna ask the same question. It's gonna place 1 plus the max. Obviously, it's gonna take the 2. 2 is bigger than 1. 1 plus 2, you get 3, and that's how you get the final output of like 3 per se. And that's the gist of this whole Leetcode question per se in the playoff series per se. And if you were to ask me what spell is it actually casting for this tree, I'll tell you, smart maneuver. Smart maneuver. It's like constantly asking this same old question and then summing up the value and then return back up. Summing up the value, go back up, summing up the value based on this, and sum back up and go back up. And use the same old item again. You know? That's what it's doing. And I mean, it eventually does fulfill our core objective at the end of the day, which is it's free, right? It's true, right? I mean, the Leetcode rulebook is talking a lot about I want you to get me the max depth, and by you smartly maneuvering to be able to actually collate the accumulated value per se, I think this spell is very much useful to fight against the core objective, which is what we want, which is getting the max depth right. And using this, it does solve the problem. And obviously we always have like brute force to actually fight against the character per se. And I mean I honestly, because brute force, it doesn't know where to go. Like, it doesn't know like if this like the max, like well, what if the brute force like think that, oh, I try to go deeper towards the left, oh, I found a value, it's 1, but it's not, it's 3. So to me, to that, like this is operation Z per se, like you go one direction, what if you go the wrong direction per se, and you return like a false value, which is returning a 2 for operation Z as opposed to operation X, where you actually know where to go, you smartly maneuver based on a condition set that you set for yourself in order to find the 3, like going through the X operation to actually find the 3. To me, to that, that's one way to actually argue to brute force, that saying that, hey, yo, I beat you, you know, whatever you're doing here, it's not good, because you, what if like the max value is at the right side and not at the left side? It's telling brute force, get out of the way, let 3 do the job. And the second item I actually like to actually emphasize is this, that maybe it comes down to efficiency. Yeah, sure, okay, I come here, I find the max, I go right side, I find the max as well. But it's like going every single possible path per se, and I believe that operation Z per se would then take up like a big O of like, I don't know, n square or n's, but at least for operation X, it's just taking a time out of like big O of like log n, because you're constantly cutting by half, you know, because you already know that where to go per se. But wait, no, I think this explanation doesn't fulfill much, so I'm gonna say that I'm gonna just return back to the first argument that I did, the first explanation that I did, and I'm just gonna stop there to fight against the brute force at least. So yep, I just gonna say that the very first explanation of operation Z, which is that what if you go on to the wrong direction? You're messed up already. You don't give like the rulebook the correct answer. That's why you need the operation X, which is going the right way and trying to actually really find the true max value per se. And that's operation X. And that's how we beat the brute force. And yep, everything comes to an end.